Okay, draw the structure of unbranched alkenes. So what you do is you will first draw the two carbon with the double bond. Then you go across it, right? You just count that each carbon must have 4 bonds. So 2 bonds here, so another bond here, and another bond here. So you repeat the same step for the other carbon. Then you end up with this. So then another example here, let's do this one. I explain this. So 4 carbon. Butene means 4 carbon. So and it's E and E, right? So it's an alkene. So I start with the double bond again. So 2 carbon. Then 1, 2, 3, 4, right? So then because there's another 2 carbon, so I add another 2 carbon. So then after that, I go to the other 2 carbon and make sure that there are 4 bonds around it. So that's how I get this. So this one and this one is also called butene, but then the double bond is found in a different location. So there's 1, 2. So there's a special name for this two. That means they are called isomers, and isomers are not in your syllabus. So then you see that the boiling point would increase when the number of carbon increase. Yeah. Then the explanation for that is exactly the same as the explanation to explain that physical property trend, right? In alkanes. Okay, then how do I convert the structural formula to the condensed formula? Or how do I use the condensed formula to predict the structural formula? I mean, you have to know how to read. That's why I'm actually asking you.
So the 3 different fields, like
Yeah.
the different C's will tell you which hydrogen.
So it's like different group, right?
Yeah.
So like this. So one C like that, the other C like that. So then this side is CH2,
The other
the other side is CH2.
Yeah, okay.
So because CH2, CH2. Then over here, this one, the butene. So it's like this. 1, 2, then 3, 4.
Okay.
So then this side is CH3, this side is CH2, CH, and then CH2. Salah. This one is 2 here. Okay?
Yeah.
So this is how you read. So in questions, in MCQs, in structured questions, they can give you the condensed form and then assume you can identify what it is.
Okay.
But sometimes it's not very clear whether it's alkane or alkene, then you draw out. So these are unbranched alkenes. Unbranched means you have all the carbon in the straight line.
Okay.
This is unbranched. So back to this again. This is 2. So this is unbranched. So I have to tell you what is branch for you to recognize. Because if you've not seen before, you wouldn't know what it is. So I want to draw a butene 4 carbon. I can do this. 4 carbon, right?
Yeah.
1, 2, 3, 4. So as long as there's 4 and there's a double bond, then it's a butene. So, but you see, it's not a straight line anymore like this one. You see the difference?
Yeah.
The layout of the carbon. So the one I drew on top, that is a branched alkene. It's a branch molecule.
Yeah.
If there's a need for it, then you know what it is. Then, other than asking you to draw the structural formula, they can also ask you to draw the dot and cross diagram of alkene.
Oh, dot and cross.
So it is also a question. So they will ask you for the dot and cross diagram for alkene molecules. Same for alkanes, they also can ask you for that thing. So dot and cross diagram. So the double bond is here. When there's a double bond, you share 4 electrons or 2 pairs of electrons. Then when there's a single bond, then it's 1 pair of electrons. So this one is propene, and then this is ethene. Then make sure that every carbon, the valence shell has 8 electrons. Yeah. Pentene is an alkene containing 5 carbon atoms. Write the molecular formula.
Pentene is an alkene. So C5H12.
This is a pentene, so it's CnH2n.
Yeah, so it's C5, right? C5H12,
Yeah.
right?
Huh? Why H12? The general formula for alkene.
Isn't it 2n plus 2? No?
No, that one is alkene.
Oh, okay. So it's just 10 now. C5H10.
Yeah. That's why that's why just now at the start of alkenes, I even go and circle and then I tell you the difference between the two. Yeah, because of that. Pentene is an alkene containing 5 carbon atoms.
alkene combination.
So you take some time, try it first, then we continue.
Is it 4 carbons with just single bond, then one with double?
Yes. So we first start with the double bond, right? Because it's alkene. Then I know there's 5. So I go to the double bond, I draw 4 bonds around the carbon. So I make sure everyone has 4. Then after that, then I can continue. I can choose to add 1 on one side, 2, and then 2 on one side, that kind of thing. Or the other way around is possible. Or I can choose to add all 3 on one side. It's not wrong. So then full of possibility. Then after that, I go to every carbon, make sure that there's 4 bonds around it.
Okay.
Then you get the answer. Last step, put all the hydrogen in. If you don't put all the hydrogen in, right, and lazy write like this, right, you will not get that much.
Yeah. Okay.
So you see, that's how then their answer is a bit different. The position of the double bond doesn't matter for you because there is more intricate way of naming these molecules. Then when that happens, right, then the name is very detailed, and then it will dictate where the carbon double bond is. Not in syllabus.